Welcome back to AIM Chemistry, Learn Chemistry with Dr. Poonam. We will take example hydrochloric acid aqueous form plus ammonia, which is also in aqueous form. So students, if we see here, now HCl is an acid, so here we can call it as a Bronsted-Lowry acid. Bronsted-Lowry acid, and ammonia is base. We called it as, because we are defining by Bronsted-Lowry concept, so Bronsted-Lowry base. Now students, as we understood that acid is proton donor, so it will donate proton, and it will donate proton to ammonia. So ammonia is base, which is proton acceptor. So if you see student, after donation of this 1H plus, after donation of this 1H plus, let us see, it will be ammonium ion, because it is gaining one proton, so it will be NH4 plus, and it is losing one H plus, so it will be chloride ion. So this is called ammonium ion, and it is chloride ion. Now student, how to identify conjugate acid base pair? Now we see that HCl is an acid, so now this chloride ion is able to gain proton because it has a Cl minus charge, so it is able to gain H plus. So HCl, this is acid, and it is able to gain H plus, so that's why we call it as a conjugate base. Now at the same time, this is ammonium ion. Ammonium ion is able to lose this H plus, is able to donate this H plus, and it can form ammonia, so we called it conjugate acid. So student, here clearly we can say that HCl is giving its conjugate base chloride ion, and ammonia is base, which is giving its conjugate acid. So this pair, what is a conjugate means? It is in couple student, so whatever it is in a pair, we call it conjugate acid base pair. Again, we will take one example: water plus liquid plus ammonia in aqueous form. So student, again this is in equilibrium. So here water behaves like acid, as we know that water is an amphotericity, that also we will discuss, and this is base, so we call it as a Bronsted-Lowry acid and Bronsted-Lowry base. So this will donate one H plus to ammonia, so as soon as it will gain, it will form ammonium ion plus, this water is losing H plus, so it will be OH minus ion. So is possible students, take a pause, okay, pause this video and just find out which is a conjugate acid base pair. Now if this is acid, and after donating H plus, it is giving NH4 plus, so acid is, because OH minus ion is again able to gain one H plus, and it will give water molecule. So there is a gain, means it is a proton acceptor. So this, when it is a proton acceptor, this is called conjugate base. So here student, water and OH minus are acid and conjugate base pair, and this is base, because when ammonium ion will lose one H plus, that time we will get ammonia, so it is able to donate H plus, so this is the reason it is conjugate base. So here student, acid base pair is water, this is acid, and its conjugate base is OH minus. This is conjugate acid base pair. And next to it, ammonia is a base and which forms ammonium ion, which is conjugate, sorry student, it's a conjugate acid. So this is a conjugate acid base pair. Now students, so after discussing few examples, now it's a right time what is the exact definition of conjugate acid base pair. So conjugate acid base pair means students, so just there are species which are differ by only one proton. Those species which are differ from each other by one proton, actually they can be formed from each other mutually by the gain or loss of proton. See, there is a mutual acceptance and donation of hydrogen ion is called as conjugate acid base pair. This is Bronsted-Lowry acid which has H plus, which donate this H plus to Bronsted-Lowry base. So after donating, this will able to again donate H plus and this will be conjugate base. So acid base pair, and there is a formation of acid base pair. So student, you can clearly see that there is a difference of one proton. Here one proton, there is a lack of one proton. Here one proton, and there is a lack of one proton. So when the acid base species differ by one proton, or they can mutually accept and donate hydrogen ion, any one of the definition is acceptable by ministry. So student, you can note down definition. Pause video and note down definition. Okay, because we will discuss again one example. Now student, this is one question. If hydronium ion is an acid, according to Bronsted-Lowry theory, what is conjugate base of this acid? So first you have to see, this is acid, H3O plus acid. If it is acid, that means it will donate one H plus. So after removing one H plus, there will be water, and this will be students, it can, this is the conjugate base of acid H3O plus, conjugate base. So option C is correct answer. So in this way students, we discuss the concept of Bronsted-Lowry acids and base and conjugate acid and base. I hope you noted down all important points and definition. Thank you for watching students.